Have you ever wondered how a car engine works? Well, let me break it down for you. The engine is the heart of any vehicle, and it's responsible for converting fuel into power to propel the car. The process is intricate and fascinating, so let's dive in. The car engine is typically made up of several key components. First, there's the cylinder block, which houses the cylinders where the fuel combustion takes place. Each cylinder contains a piston that moves up and down within it. Connected to the piston is a connecting rod, which is linked to the crankshaft. The crankshaft is responsible for converting the linear motion of the piston into rotational motion. To understand the engine's operation, we need to look at the four-stroke combustion cycle, also known as the Otto cycle. These four strokes are intake, compression, power, and exhaust. Starting with the intake stroke, the piston moves down, creating a vacuum that draws a mixture of air and fuel into the combustion chamber through the intake valve. This mixture is vital for the engine's operation, as it provides the necessary fuel source. Once the intake stroke is complete, the piston starts to move back up during the compression stroke, compressing the air-fuel mixture. Compression is crucial because it increases the mixture's pressure and temperature, leading to a more powerful explosion during the power stroke. After the compression stroke, we move on to the power stroke. At this point, the spark plug ignites the compressed air-fuel mixture, resulting in a controlled explosion. The energy released from this explosion forces the piston back down with tremendous force. This downward motion is what converts the chemical energy in the fuel into mechanical energy necessary to turn the wheels. Finally, we have the exhaust stroke. As the piston moves back up, the exhaust valve opens, allowing the burned gases to exit the combustion chamber and flow out through the exhaust system. This process prepares the engine for the next cycle, beginning with the intake stroke once again. To make all these components work together seamlessly, there are various subsystems that aid in the engine's operation. Let's explore a couple of them. One vital component is the fuel system. It ensures that the engine receives the proper amount of fuel for combustion. It typically consists of a fuel tank, fuel pump, fuel injectors or carburetors, and a fuel rail. The fuel pump delivers fuel from the tank to the injectors or carburetors, which then distribute it into the combustion chamber in a precise manner. The fuel system's efficiency directly affects how well the engine performs. Another vital subsystem is the cooling system. Engines generate a significant amount of heat, and if left unchecked, it can lead to overheating and engine damage. The cooling system consists of a radiator, water pump, thermostat, coolant, and various hoses. The coolant, typically a mixture of water and antifreeze, circulates through the engine, absorbing the heat generated by combustion. It then passes through the radiator, where the heat is dissipated before returning to the engine. In addition to the fuel and cooling systems, the engine also relies on the lubrication system to keep all the moving parts working smoothly. It uses engine oil to reduce friction between the components and prevent them from seizing. The oil is pumped by the oil pump to various parts of the engine, ensuring they stay lubricated and cooled for optimal performance. Now that we've covered the basics, it's essential to touch upon engine types briefly. The most common type of engine found in passenger cars is the internal combustion engine, which can be either gasoline or diesel powered. Gasoline engines use spark plugs to ignite the air-fuel mixture, while diesel engines rely on the heat generated by compression alone